Okay, Chapter 5, Linux, Part 2. I neglected to mention that in the first one. That was Part 1. This is Part 2. So we'll start looking at, what will we start looking at? Using the comm command. So it says, like unique, comm identifies duplicate lines. So remember what unique did. It showed us consecutive lines. Okay, so with this, does not delete duplicate lines and works with two files rather than one. So what we're doing is comparing. Now, notice what it shows us here. -1, do not display lines that are only in file 1. So we're going to look at the different lines actually, or the lines that are different between file 1 and file 2. -2, so what you're doing with this first -1 option is just not displaying whatever is different in file 1. -2 says do not display lines that are only in file 2. -3 says do not display lines appearing in both file 1 and 2. So this -3 in this comm command is not displaying lines that appear in both file 1 and file 2, so that we really do get the difference between the two. So let's go ahead and run this command, and this is comm-3. Now the first file that we compare, comm1 sort. Let me do this first. Cat comm1 sort. Okay, that's what that looks like, kind of a stripped down version of that zoo file. The next one we want to look at just to verify is comm2 sort. Okay, so that we do see a difference. Actually, we see camels and elephants, that's true, and then we see monkeys versus lions. So we should see a difference. So I'm setting this up so that we can see a difference. comm-3, comm1 sort, and that's the first file, comm2 sort. Okay, so what this is telling us, this output, which looks just like this, it says that lions does not appear in comm1 sort. Okay, which I think we verified. comm1 sort. Lions does not appear in this comm1 sort. Okay, now it says monkeys does not appear in the comm2 file. Okay, so, and we show that monkeys does not appear in the comm2 file. So it shows us, this output shows us or compares these files. Okay, so again, what we're looking at is comm-3, comm1 sort, and comm2 sort. It shows us, I'm just thinking about this, does not appear in, yes, that's right. Doesn't appear in the first file. This doesn't appear in the second. Okay, so that's how that works. It's a little confusing, but basically you're trying to figure out what is in, or what's in the second that may not be in the first. What are unique between the two files? That's really what you're looking at. Okay. Next, we'll look at the diff command. Now, this is commonly used to determine the minimal set of changes needed to convert file 1 to file 2. So what are the steps it takes to actually get file 1 to file 2? Here's some commands that goes with it. What we want to look at is we have zoo1, and that's what zoo1 will look like. We have zoo2, and that's what zoo2 will look like. Now, when we go ahead and run this command, it's diff the first file and then the second file. So we're going to get some weird stuff here. It's going to have some output that looks like 3D2 and then lions line, and then 5D3 the elephants line. Well, what this means is, and I've color coded this so it makes a little more sense, delete third and fifth line from zoo1, okay, third and fifth line from zoo1 to make it look like zoo2. Now, this is saying delete the third line, means zoo2 will be the same as zoo1 up to but not including line 2 at this point. Okay, so you delete that third line, then you delete the fifth line, and at that point it says means zoo2 will be the same as zoo1 up to but not including line 3. Okay, so it's really kind of cryptic. There's a few exercises that deal with using diff, Um, it's advantageous in very large files, but the smaller files that we're using, I can't see a real advantage in using this particular command. Now, changing this around, diff zoo2 to zoo1. So what we're doing is making zoo2 look like zoo1. So in the one case, we were deleting lines. Okay, we're deleting lines here. In this case, we need to add some. So what this is saying is add the third line of zoo1 after the second line of zoo2. So add the third line of zoo1 after the second line in zoo2. Okay, this statement says add the fifth line of zoo1, that's this one, after the third line of zoo2. Okay, so that's actually going to make zoo2 look like zoo1. Again, in the first case, it makes zoo1 look like zoo2. Now let's go ahead and run the command. Diff, and I think the first one was zoo1, and make it look like zoo2. So we're going to be deleting lions and elephants, the third and the fifth lines. Okay, and then if we change this around, zoo2 to zoo1, we need to add lines. Okay, so we're adding lions and the elephants line. Okay, pretty cryptic, it really is. But you know, this is what it is, and that's the deal. Now, the final piece of part 2 is simply a word count. So this calculates the line, word, and byte counts of the specified files. So all we're going to do is use zoo1. We're going to scroll it up just a little bit, and WC, okay, WC, and then the file name. Now our file is going to look a little different than what we're seeing here. I'm going to scroll that up just a bit. What we're seeing are, in our case, okay, well let's look. Take a look at this file. Okay, you notice there's no spaces. There's only some dots that are separating words. There's colons. Okay, so what we're seeing is 6 words. See, 1, 2, 3, 4, 5, 6. Because there is no space separation, each one of these areas, each one of those lines looks like one word. Okay, one word, one word. Or I'm sorry, 6 lines. 6 lines. Now it says 8 words. Where is the space at? Right there. Look at that. Okay, so let me do this. Let me restate this. When we type in WC zoo1, this is the zoo1 file. What we're seeing are 6 lines, 1, 2, 3, 4, 5, 6. That's good. We're seeing 8 words. Anything that isn't separated by a space is considered a word. That first line is considered one word. Now lions, raw, and then there's a space, that's considered a separate word. And then meat, 4,000, and so on is a separate word. The same is true here, so we have 1, 2, 3, 4, 5, 6, 7, 8 words. 170 bytes, and then the file name. In this example, we have 8 lines, and that's the example on the right. 8 lines, 10 words, and 228 bytes. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so that's the word count within Linux. Okay, so, and again, that space makes the separate word. Okay, so the rest of this will start at the sed command, which we do quite a lot with, actually. And so I'll have a little bit more stuff about that in the next video, part 3. So thank you.